Now tell me about the pillars.
Well, somebody used this as a home remedy. What had happened, if you can see at the floor, they put a French drain in, but unfortunately didn't have the knowledge to realize they had what's called a monolithic pour, so they broke a third of the footing away. So as that wall started to close that gap, they decided to put these pipes in, kind of like this pipes for the support in the center column, the main girder. But what they did is they put these pipes up, and then you can see they blocked them at the top.
Drop that way.
And they blocked them at the top, and you can actually see the bow in the pipe, because see, pipe is not structural sideways. Pipe is structural vertically, so if you're compressing it, it has a lot of bearing. But from the side, it's just going to bend. Now you can see here, I'm actually holding, this is level, the bubble is right on the money, and you can see that this upper part is still maintaining level even though the wall has pushed it away, and this is slid. But you can see there's about a 3/4 inch gap at the bottom, so that pipe has got a lot of weight on it. The problem is, if you can see up top in here, all they did was put one piece of, it looks like a 2x10, and they put 4 nails on this side and 4 nails on that side. This one has 4 and 4, that one has 3 and 3. What they're trying to do is transfer this load, so that's one of the reasons this kind of maintained the level, was the fact that as this started to get some pressure on it, this will bow up to 10%, and then the load was transferred up to here, which in turn pushed the wall that way. Now you can see over here was an old stairwell, and you can see in the stairwell where even this has a slight bow into it as that wood's transferring the load across where the old stairwell used to be. They should have blocked that all the way through to the main girder, which would have helped quite a bit. Now I'm just a few feet down from where that last pipe is we saw, and you can see here where there used to be a pipe, but obviously they took it out. There is some blocking up here in the ceiling, if you want to take a look up here. There's still some blocking that remains, but apparently this pipe has failed. You can notice here we have a cracked mortar joint, a cracked mortar joint, a cracked mortar joint, a cracked mortar joint, another cracked one, another cracked one. So what's happening, this wall is coming out uniformly, and every joint is failing. Again, our Geo-Lock anchor will be set in this area here. We'll cover at least 3 to 4 of these blocks, and slowly over time we'll be able to push that back in. The homeowner here has opted not to have us excavate and pop the wall back, but to do it over time, because obviously it's a little more affordable, and that's fine. At least they know they have the safety and protection of the Geo-Lock system. You can see over here, if you want to pan to the right a little bit, where the mortar covering that was put over here at one time is actually blown off from the movement, and you can actually see the wide gap in the mortar joints, even more revealing here than right here, because of that coating that was put over there.
Alright, we're going to come 36 inches down from our top block. That's right here on the crack that we see. So when we're done, our plate sitting flush and level is going to be sitting right here.
Pretty super cool shovel, can I get it?
This is our pull rod. When we pushed our rods all the way in, that's so we make sure that we're in our hole that we augered out. And then we install our plates. We put the nuts on the plate, and then we pull the rod back until the nut seats into the plate and it's tight up against the earth. Not too tight, but pretty tight. You can see this is just a weird shaped piece of metal we use, and I'll put this rod driver on it. I'll turn it on, and I'll push it back. It slips right up on here. I can just pull it back to where it needs to be. This is a hammer gun. I'm taking it off now. Scott's using pressure to insert that sleeve in. That sleeve's going to help create a better seal and push some of that wax to the outside of the hole to make sure she's not only sealed from the inside but sealed from the outside. He waxed it before he started. He waxed the tube itself. He waxed it when he got halfway in, and now that he's done, he's going to go ahead and wax it again. This is to prevent water from penetrating through the break in the cinder block that we created. Now, if you look at every single earth anchor that we put in, every single Geo-Lock anchor that we install is installed on at least could be a couple of degrees down, but it's always on a downhill pitch, simply because water doesn't run uphill. We know it's a problem. We've done this long enough that we know what to do to solve it. You're not going to have water leaking out of where we install our Geo-Lock anchors. What I'm doing right now is this impact gun is going to start pulling this plate towards that plate, because the earth, the way that the force is projected from the plate outside, the way the plate's designed and just the way things are, is the plates, say, this big crossed outside, and as it gets pressure in, that pressure goes out on like a 45 or like 50-degree angle or something like that, so it's increased. It's not just the weight of the dirt right in front of the plate pulling, it spreads out and relies on itself. So as I tighten this bolt up, that plate's not going anywhere. This plate's the one that moves, and this plate will pull the wall back. So what I'm going to do, this is an impact gun that's set to, I don't know, 80 pounds or 150, whatever an impact gun is. But I'll start to see it as it slows down, as it's turning. That means it's getting a little closer to 80 pounds and it's getting real tight. So as this slows down, you'll see it turn real fast, and then it'll just, when it starts doing that, I'm going to let go, and I'm going to grab my my torque wrench, which is set to a specific amount of pounds. 40, I'll do 40, and then I'll do 50, then I'll do 60. Unless I see something happening, some trouble with the wall, that the wall can't take all this movement at once, I'll put her all the way up to 80. And I'll do that with the torque wrench, but I'll tighten her up with this just to save me an hour. You see that? How it started to slow down? You can see the same thing on this. We got the 70s.